All right. We seem to be ready to go. Let's go ahead and share this real quick just to get started. Make sure that we are indeed live. And we are live. Okay, let's just share that we are live right now. I am currently live and will be live for the next 2 hours more or less. Make sure to join the YouTube or Twitch stream to watch me do some LeetCode and building some apps live. I'll see you there. Hello, friend. How you doing, friend? Give me 1 second. Let me just make sure that I have the right stuff here. Okay, I have multi-audio. And let me just get rid of my Bluetooth devices that are connected here. What up, friend? What up? Welcome. We're gonna be doing some live coding today. So I made a post on Instagram asking people what I should be doing, and I have a tie between two things. I have a tie between doing some LeetCode and doing some live app coding. So I'll probably do that. I'm gonna go for two LeetCode problems, just try to solve them, and then we'll go ahead and try to build an app. So we'll see what you guys want me to build. Let me just do this real quick here. So YouTube live. Can you believe I'm your only follower here on Twitch? Yeah, dude, I mean, I pretty much I don't think I ever really did any streaming on Twitch. I think I did, like, I would do some live streamings every now and then, but nothing really, like, actually pushing it and have people join. So literally yesterday was like my first live stream. So you're one of the OG. You're one of the OG. Link in bio. Just trying to post this over here. All right. Let's see where we are. I'm ready to learn something new today. Yes. I'm gonna try and go through two problems that I found that I've done in the past, and one of them is easy and one of them is medium, and they're similar problems. They ask pretty much for the same. They just have like a little bit of differences here and there on the actual like what the problem is asking. So we'll go through some of them in just a second. So let's go ahead and get that started. I might want to give me 1 second because I want to go ahead and change my chat because I feel it's too intrusive there. It's like in the middle of the thing, and it looks too prominent. So maybe I can just like change the settings here to have something more normal. There we go. So how about we have something like this right here? This is gonna be good. So let me go ahead and change that from my okay. Can I do that actually? Just trying to get my chat to look a bit better because I feel that it's like in the middle of the whole thing and it looks way too big, dude. So I want to make sure that, I don't know, whatever I'm putting there, it actually looks good. So, okay, there we go. This is probably a bit better. So let me transition here, and where I'm gonna put my chat, I'm actually gonna put my chat here on the left. Let me try and make this a bit like that. And can I actually, okay, I think that might be good for now. That way chat is not covering the code there. All right, so let's go ahead and go through this problem real quick. We're gonna solve two different types of two-sum. I'm gonna solve two-sum 1, which is an easy, and then I'm gonna solve two-sum 2, which is a medium problem. They're very similar in what they're asking, but they have, you know, just a couple of things here and there that might differ. So we're gonna try and go through that. So yeah, let's go ahead and get started. All right. Any ideas? Have you guys solved this before? Have you solved this before? Or never even seen it? I don't know. This problem is kind of it's common. It keeps coming up in different, depending on what path you're doing. Like if you're doing the top 150 interviews or the top 75, this keeps coming up. So I don't know if you've solved it before, or if this is just the first time that you ever even see it, and then that's totally fine. But trying to see what approach you would go for. Let's see here. I want to make sure that I'm... Okay, so let's go ahead and solve this one. Let's go ahead and solve our two-sum. So what are we doing here? Well, in here we are given an array of integers, and the array is just named nums. So we're given here an array of integers and an integer target. So we're given our target right here. So we're given an array of integers and an integer target. And then we are asked to return the indices of the two numbers such that they add up to the target. Okay, so we need to find two numbers in our array that match, you know, that added together give my target. So they ask us to return the indices of those two numbers in the array if they actually add up or match to the target. And what else do we see here? You may assume that each input would have exactly one solution. So we're not going to find multiple solutions, which is good. They're letting us know that if it exists, there's only going to be one solution. And you may not use the same element twice. That makes sense, right? Like for example, if we have right here this list or this array and we're given 2, 7, 11, 15 and our target is, let's say, 22, we cannot use 2 11s to say that we do have 22. So we would have to use separate items because we cannot use the same element twice. So if we're gonna try and decide if the item is there, it has to be two different items. So how do we do this? Well, let's see what we have right here. So in this case, in some of the examples, we have 2, 7, 11, 15 with a target 9, and then we return 0 and 1 because, well, item at index 0 would be 2, item at index 1 would be 7, and if we add them together, 2 and 7, that indeed does 11. Same with this one, we have a target of 6, and in this case we return the index 1 and index 2 because 2 and 4 indeed make up 6, and if we have in this one just 3 and 3 and target 6, and we return 0 and 1. Okay, only one valid answer exists. So only one valid answer exists, but it says that we can return the answer in any order. So what that tells me is that if we return 1, 0 or 0, 1, then we can try and find that. Use a for loop to iterate and look if the two numbers add up to 9 or something. Yes, so that's actually an approach. That's actually a good approach, and that's what I would consider like brute force. So let's go ahead and try and do that. So if we use a for loop, I would actually have to use 2 for loops, right? I would actually have to use 2 for loops because for every item in my array, I have to check every other item in the array to make sure that the item exists. So we would do something like for int I equals 0, I is less than num.length, and we increment I. So we're gonna go through each item in the array, and then for each of those items, so int j equals 0, j is less than num.length as well, and then we j++. And what we're doing here is that we're gonna go, and I'm following your approach just to see if we can solve it like this, but basically we're using 2 for loops, and then we are going for every item in my array, then I'm gonna go through every other item in my array, and I'm gonna try and check if the items match, right? So let's say we start at 0, then we would go, let's see with this one, we would have I here, and then j will be checking every other item. So we would check it's 2 plus 7 equal to 9, it's 11 plus 2 equal to 9, it's 15 plus 2 equal to 9, and then do the same for the other ones until we find our values. So one thing that we do want to do is if I is equal to j, then we just want to continue. Why do we want to continue if I is equal to j? Is because they tell us here that we cannot use the same element twice. So if my I is equal to my j, and for example here, let's say that we had target 4, and if my I and my j are both at the same spot, then that would technically say that it is a valid case, and it would try to return 0 and 0, but that's not allowed based on what they tell us here. So we can only use the same element once. So you may not use the same element twice. Okay, so assuming that the two values are equal, we're just gonna continue on one loop, and then on the next one I'm just gonna check if my nums at I plus the nums at j is equal to my target, right? So if the number, the first number is equal to the second number that or the sum of the two numbers are equal to the target over here, then we know we can return what we need to return. So in this case, it's asking us to return an array of integer. So I'm just gonna do a new int array, and in here I'm gonna have I comma j. Right, because if we do find the two values that match the target, then we return those two values. Otherwise, we keep going. And then lastly, if we just reach the end and we didn't find anything, we're just going to return an empty array, right? So let's walk through this again and see what we're doing. So if, maybe we can take this down just for, I don't know, I like having things in the same line just so that we don't have a lot of stuff like piling up. But, okay, so for every item in my array, I'm going to go through every other item, and then I'm going to check if the item at I is equal to the item at j. If I is equal to j, that is the actual pointers or the actual indices are the same, I continue because I can't use the same element twice. Otherwise, I'm going to check if my number at I is plus the number at j is equal to my target. Then I found my answer. I can return that here. And then lastly, if I went all the way through all of my items and I didn't find anything, then I can return an empty array. Let me run this just to make sure that we have it. And yeah, there we go. So this works, right? At least it passes my 3 test cases. Let me submit this. And it actually submits it. So it says that I'm running very, very slow. And yeah, I implemented this just to kind of show that this is indeed an approach. And that's probably what I would think the first time, right? Like if I'm looking at this and I'm trying to compare one item to every other item, I would definitely probably just go with a double loop. But now let's go ahead and take a look, right? Because it says that we're running in 104 milliseconds and we're all the way back here. But we see that some people are getting answers that are running like 0 milliseconds or even like 40 milliseconds, right? Like it seems that this is very big. So let's try to analyze here the runtime complexity of this algorithm. What do you guys think this runtime complexity would be? And first of all, do you know what runtime complexity is? If you don't know what runtime complexity is, that's fine, but I can explain it as well. But if you do know, what do you think the runtime complexity of this algorithm would be? And again, if you don't know what runtime complexity is, that's totally okay. I can try and cover it as well. I want to make sure that we understand why an algorithm or how an algorithm is, it's considered fast or not fast and so on. Yeah, it's big O notation. Yes, it's big O notation. So no worries. We're going to go ahead and solve it in just a second. So let's look at the runtime complexity here. So as you say, it is big O, right? It's big O notation. So how do we find the big O notation here? Well, we mainly want to look at things like loops and operations that we're doing, right? So we want to make sure that we consider, based on our input size, how many times this algorithm is running, right? So based on our input size and our nums, we are running through the array once, right? So we're running through the array once. That means that if I have 3 items, I'm only going to run through the array 3 times, or I'm only going to loop 3 times. If my array has 1,000,000 items, I'm going to loop 1,000,000 times, right? So with this first for loop right here, we are running n times. So we are running n times. Where n is the nums.length, right? Or the input size. So in the first for loop, we're running n times. And n is just the amount of, like, how many items we have in our array. So n is going to be 1 if our array only has 1 item. Or it's going to be, 1,000,000 if my array has 1,000,000 items. So that's in the first for loop. But then we have a nested for loop. So that means that for every single item in my array, I'm going to run through every other single item in my array and try to compare them. So that means that for every n, or for every item, I'm going to run n more times. So since I have the 2 for loops, I would be running n times n times, because for every item, we're going to run n times again. So I would be running n times n, which at the end of the day is just n squared. N squared. So our algorithm, as it has right here, with 2 for loops, runs in O of n squared, which this is just called quadratic. So this runs in quadratic time, right? O of n squared. Does that make sense? Like, did that explanation of big O or runtime complexity make sense here with these 2 for loops? Because basically we're running through every item in my array, but then for every single item in that array, I'm running through every other item there. So I'm running n times n, which is equal to n squared. Okay, cool. So we're running n squared, and n squared is, although it solves the problem, which is ideally what we want to do, and this is what I recommend everyone when they're going through their interviews, is always make sure that you solve the problem. Even if you don't have the best, fastest algorithm, if you don't solve the problem, you're definitely failing the interview. Like that's a given. Like unless you're going for like a very internship or like very, very entry level, if you do not solve a problem during the interview, you're definitely not passing the interview. So make sure that you solve it. And this approach gets it done. As we saw, it passes all of our test cases. It works. Great. But now, can we improve this algorithm, right? Now that we know what the runtime of this is, which is O of n squared, how do we improve it? Like, can we actually make this run faster? And at least some of these, like this metrics right here, might give us a little bit of information that we indeed can run a whole lot faster. We can run in even 0 milliseconds according to this. I don't know if we're going to get there, but we're going to try and make it better. So what do we do? How do we run this in faster time? And I think it even tells us over here, can you come up with an algorithm that is less than O of n squared time complexity? So the problem is even asking us, okay, you probably solved it with the 2 loops, which is fine, but can you solve it with something better? I don't know. What do you think? What do you think? Can we do it? Can you think of any way that we can do this? And hello, Mohammed. Welcome. So can we actually do this in something faster than O of n squared? And just give me your thoughts. What do you think? You think it's possible? No, maybe this is just the fastest. Or I just simply don't know. I don't know. And we'll take a look, see if we can improve this a bit. But yeah, but just to recap, always make sure that you solve the problem. It doesn't even matter if you have like an O of n cube or something, or like an n factorial. It's going to be terrible, but as long as you solve the problem, the interviewer might still give you some points just because you solved it. So you can do this a little bit different. And so, yeah, first just try to solve the problem, then try to talk to the interviewer. Because most of the times, you'll realize that once you solve the problem, the interviewer tells you like, great, yeah, we solved it. So they will ask you like, what is the runtime of the algorithm? Like they want to make sure that you know how to calculate the runtime of the algorithm. So they'll ask you like, okay, what is the runtime of this algorithm? And then once you determine the runtime, so in this case we determine that it is quadratic time or O of n squared, then they might ask you, how can we improve on this? Or can we even improve on this? And a lot of times you might have the time to code it, but a lot of times you might have to just talk to the interviewer and kind of go through your better approach. And you might be able to explain like, yeah, you know, we maybe can do this, this, and this to optimize it and so on. So, yeah, let's go ahead and solve it. And yep, yeah, Mohammed, I think you're on the right track. The best way to solve this, at least that I can think of in the moment, there's probably other even better ways to do it, but I think one of the easiest ways to solve this is using a hash, either a hash set or a hash map. It really depends on what your preference. So let's go ahead and try and solve it with a hash map. So let's go ahead and keep in mind this algorithm right here. I'm just gonna comment it out for now, but just so that we can keep it in mind and understand that it was O of n squared. So let's go ahead and try and solve it with a hash map and see if we can improve on this. So if you're not familiar with a hash map is a key value pair. What does that mean? So you can think of like a JSON object if you've worked with JSON before. So basically a hash map resembles something very similar to this. So a hash map resembles something very similar to this, where I have my key and then I have a value over here. So this is pretty much what a hash map represents. Of course, it has like a bunch of other things inside to make it faster, make it work smoother, and so on. But in a nutshell, a hash map is just a key value pair And the good thing about this is that one, keys have to be unique. So we know that if there's something in my hash map, there can only be one key that's named key. Like I cannot do this, for example, like having two keys be the same, value 2. I cannot do this because in my hash map, I always have to have one key per value. Like I cannot have multiple keys that are the same. Now, I can do this. I can have key and key 2, and I can have the values be the same. This is okay. The key has to be unique, but the value doesn't have to be unique. The value can be the same as other keys. As long as our keys are unique, then we know that we're good to go. And also the good thing about a hash map is that we can add and get items from our hash map in constant time. What does constant time mean? That no matter how many items are in my hash map, it doesn't matter how many items are in my hash map, I can always get them at the same time. So if I have one item or a million items in my hash map, since I can add and get items to and from my hash map, I can always get them in constant time. So, okay, that was just a quick refresher there of hash maps. If you guys have any other questions, just let me know. More than happy to cover more of that. But let's go ahead and use a hash map here. So the first thing that I'm thinking is I'm going to declare a hash map that's going to go, this is going to be a new hash map. And it's going to have integers as the key and integers as the value. And why am I doing this? Well, first, I know that my array is of integers. So I want to make sure that I can map a specific value and I can have it as my key. So I'm going to use integer for the key of the hash map. And then the value is also going to be an integer. And what am I going to store in that value? Well, what I'm going to store in the value is the index of whatever number it is. So for example, if I have this array, right, 4, 5, 6. If I have 4, 5, 6, what I'm going to do is I'm going to set the key of the item. So the key of the item is going to be 4, at least for the first one, and the value is going to be 0. So I'm going to have key 4, value 0. Why value 0? Because that's just the index or the position that my item is. Then for 5, we're gonna have key 5, value 1. Then we have key 6, value 2. So I'm gonna do this. I'm gonna store my items with the key being the actual number and then the value being the index of where that item is. Because since it's asking us to return the indices, and here it says return the indices of the two numbers, I want to make sure that I can find it, right? So I want to make sure that I still keep track of where that item was in my array so that I can return the right value. So I'm going to do something like that. Now, what am I going to do? Well, the first thing that I'm going to do is I'm going to go through every number. So I'm going to go through every number in my array. So int I equals 0, I is less than num_stand length, and then we're going to increment that I. So I'm going to go through every item in my array, and I'm going to add it to my map. So I'm going to do map.put, and again, as I said, the key is going to be the actual number, so that's going to be, you know, whatever. In this case, the keys are going to be 2, 7, 11, and 15. And the value is just going to be the index of where I'm at. So this is the first thing that I'm going to do. I'm just going through every item in my array, and I'm adding them to my map. So I'm basically just putting like, hey, if the number, put the number, in this case 2, and then set the value as 0, because that's just the index of that. And then on the next loop, we're going to do the value 7, or the key 7, and the value 1, because, well, that's just a position. And then I'll do that for every single one of them. So cool. Now I added all of the items onto my map. Now at this point I should have every item in my array in my map with just mapping from the value to the actual index of the array. Now that I already have this into my hash map, I'm gonna loop once more. I'm gonna loop through my array again. So I'm gonna loop int I equals 0, I is less than select. Oh, I have the hiccups. I plus plus. So I'm gonna loop through my array once more, and I'm gonna do the following. First, I'm just gonna go ahead and set a variable here to just keep track of the current item that I'm going through. So I'm going through my array again, and then I'm gonna check. I'm gonna do something fancy here. What am I gonna do? I'm gonna check if my map contains the key, or contains a key. So what key do I wanna find? Well, if we look at my map, let's say with this example right here, 2, 7, 11, and 15. So if I look at my map will most likely look something like this, and I'll comment it out. So my map looks something probably like this: 2, 0, 7, 1, 11, 2, 15, 3. So this is what my hash map looks like, more or less. So what do I want to do here, right? On that second time that I'm looping through my array, I want to check if an item exists in my array, or sorry, exists in my hash map. And the item that I want to check is an item that matches the sum of the value that I want to get. So what does that mean, right? Like, we know that we need to find two indices or two values that equal to the target. So for example, 2 plus 7 is equal to 9. Right, like we wanna determine if we can find this. So how about we reorganize this a bit, right? Like, what is 2 plus 7 equals to 9 equal to? Well, that's equal to 9 minus 7 is equal to 2. Right? I'm just reorganizing the equation, but it's doing the same, right? Like, I just move my 9 to the other side, and then, or actually in this case, I'm just moving the 7 to the other side. So I'm just subtracting 7 from this side, and then I get the same equation, right? It's the same equation, it's just reorganized differently. So if 2 plus 7 is equal to 9, it's the same as 9 minus 7 is equal to 2. What can we do here? Well, I'm going to do something very similar, right? If I know that I want to find two items that equal to the target, but I don't know what those two items are, how about I do the opposite, right? I check, hey, is my target minus my current value equal to a X number, right? In this case, 2. And if I have an item in my map that is equal to 2, then that means that I found my actual value, because, well, I have 7, that I'm currently looking at 7, and then I know that in my map I have 2, then I know that this is equaling 9 because, well, this equation that we have here. So let's go ahead and do that. So what would I do here? So I'm going to check if my map contains the key target minus current value. So if it contains, like, for example, 9 minus 7. So 9 minus 7 would be equal to 2. I'm basically checking if my map has the value 2, or the key 2 in this case. But I cannot just live with this. Like, I have to do an extra step. Why? Because they're telling us here, you may not use the same element twice. So we cannot use the same element twice, right? So similar to what we did over here, that we were doing, like, if I is equal to j, just continue, because that means they're the same item. I'm going to do something similar here. What I'm going to do is, hey, if I try to get that item's index, and that item index is not equal to I, so it's not equal to the same index that I'm currently at, then that means that the item is a different one. So what am I doing? I'm first checking, hey, does my map contain a key with this value right here, which is going to be equal to target minus current value because of our equation. And if that value's index is not equal to I, so it's not the same index that I'm currently looking at, then I found my item. So I can return a new integer array. I'm going to return a new integer array, and then I'm going to have the first value is just going to be the index that I'm currently at, and then the other value is the current, it's the this right here. That's the other index that I found, right? Because if, for example, I'm looking at 7, so the index over here is going to be 1 because I'm currently looking at 7. And then I did find 2, and that item or that index should be 0 because, well, we saved it beforehand by doing this initial loop right here. And that's pretty much it. And lastly, same way as the other one, if we got to the end and we didn't find anything, then I'm just going to return an empty array. And you can declare an empty array like that, or just by putting 0 in there. Doesn't really matter. I think it does the same. Let me just remove all these comments here so we can see the code better. And I think this is pretty much it. Let's go ahead and run this again. Okay, it's passing all of the test cases. And just to show over here, remember on the last attempt that did my double loop, we were running in 104 milliseconds and beating about 5% of Java users. Now, let me submit this and let's see if that changes. Look at the difference now. Now we're running in 4 milliseconds and we're beating 62% of people. Isn't that insane? Like, I'm still solving the same issue, but now I'm running 100 milliseconds less. Like, that's orders of magnitude, orders of magnitude less. We went from 104 milliseconds to 4 milliseconds. Very, very, like, fast. How do I know if I'm ready for medium or hard problems? Honestly, that can be deceiving, dude. Like, sometimes I've done some easy problems that are harder than hard problems. And sometimes I've done some hard problems that are so freaking easy. So I don't think there's like a specific, oh, now I'm ready to, because again, I think they're not really labeled properly. So I would just say, give it a shot. Give it a shot with a hard one, give it a shot with a medium, and see what they are. I mean, typically, yes, they're gonna be a bit harder if you have like a hard question, but that's not always the case. So there's no guideline. Just try it and see if you can do it. So, do you guys see the difference here? How on the first approach, we were running in O of n square or quadratic time, but now we are not running in quadratic time. And can you guys see why we're not running in O of n square anymore? Like, I do have 2 loops. Like, if you see here, I had 2 loops, and in this case, I still have 2 loops. Why is, like, what is the runtime complexity of this new approach, of this second approach that we have here? Can you guys know? Dude, I'm still sick. I need to start drinking, like, I don't know. Gotta start doing like vitamin C or something. But yeah, can you guys tell me what you think the runtime complexity of this new algorithm is? We know that the previous one was O of n square. What's the runtime of this one? And I can go through some, I'll go through explanation in just a second, but I want to give you guys some time to think about it. Let me know. Okay. I think I gave you enough time. Yeah, friend, we are running in O of n. So let's see why, right? Like, why are we running in O of n if we're still doing 2 loops? That seems kind of like counterintuitive, right? Like, if we're doing 2 loops, that sounds like it should be O of n squared, but it's not. It's O of n, and we saw it just by the runtime, right? Like, it went from 100 milliseconds, 104 milliseconds to just 4 milliseconds. So why is this linear time, or O of n? O of n, this is linear time, and not O of n squared? Well, let's look at the differences, right? In the first approach, and let me uncomment it just so that we can see it better. So on the first approach, I was going through every single item in my array, but then for every item in my array, I was going through every other item in my array. So I would start running, right? And then, okay, I'm on the first item. Let me go through every other item and check, and then come back. Okay, now let me move to the second item, and then check every other item again, and then come back. And then let me go to the third item and go to every other item. So in this case, since we have a nested loop, then we are running in n squared, because we're going for every item and going through every other item. But now you can see that this one is a bit different, right? In this case, I am not running through the array like multiple times within the same iteration. What do I mean by that? In this for loop, we do go through the array once to add the items to my hash map. So in this case, I run, so this for loop right here would be running n times, right? Running n times. So my first one is running n times. Then my second one, I'm doing the exact same thing. I'm going through the whole array again, but I'm not going through every other item as we were doing before. I'm just going through the array again, like once more. So in this case, we are also running in n times. So what does that mean? That we're running in n plus n is going to be equal to 2n. And then if we actually look at the, what they call asymptotic or asymptotic approach, is that we get rid of, like, the constant values and whatnot. So this just simplifies to O of n. Because even though we are running through the array twice, right? Because we run through the array once and then we run through the array again, we are not running in nested loops. So I do n times here, I do n times here, and then I just add them together, which gives me 2 of n, or 2n, which just simplifies to O of n. I hope that makes sense. It's just the difference between having nested loops or having the 2 loops one after each other, because we run here and then we complete that loop and then we run again. So if we don't have nested loops, typically, depending on your algorithm, of course, you're going to have linear time because of this simplification over here. Like n plus n is just 2n, but if we look at the big O notation, we get rid of that 2 because it's just not as significant as the n. So we just end up with O of n. And we do have some trade-offs here, right? Like before, if we look at the approach that we had before, it ran a whole lot slower, right? It ran in 104 milliseconds versus 4 milliseconds, but it didn't use extra memory. Like if we see here, it didn't use extra space at all because we didn't need to store anything. So in this case, our runtime complexity was O of n squared, but our space complexity was O of 1 or constant because we weren't really storing anything. But in our second approach, we improved on the runtime. We improved from n squared to O of n, but now we increased our space from constant time to linear, from constant to linear space. So we used to have O of 1 for space. Now we have O of n because we are storing the whole array into my map again. typically you will have to do that trade-off. You will have to do a trade-off between time and space. But typically you tend to prefer or prioritize faster runtime because you can always, like, space is cheap. You can always add a new memory card, like more RAM. Like, you can always add more space, but you can never add more time. Like, you can run faster. Like, something is gonna run slow, it's always gonna run slow. Like, it doesn't matter how beefed up your computer is. Like, it might run slightly better if you have like a better CPU or if you're running it on like GPUs and whatnot. But typically, if you have to choose between time and space, make sure that you simplify and make your time as fast as possible. And then your space, you can always add more item into that. I just spent 1 hour in problem 443. Could not get it for some test cases. I'm trying for off and of one space. Not sure what's 443. I'll take a look at 443 in just a second. Maybe we'll get to do that one. So yeah, it's just thinking outside of the box here and knowing the properties of a hash map. If you ever need to like fetch items fast and you need to like check if you've seen an item before, or if you have something in a sequence that you want to like count frequency or do things like that, then a hash map is probably your best friend. So yeah, this is pretty much it. I think this is the best approach right now. I'm using a hash map. We're running very, very fast. So as we saw here, we're running in like about 4 milliseconds and beating 62% of candidates. That makes sense. So yeah, but I did see that a couple of people here, dude, were having like 0 millisecond solutions. So how the heck did they do 0 millisecond solutions? I don't know. This is dumb because this is still like offense square. So I don't know. I don't like that there. Let's see what solutions like people have put here. So let's see this solution here. Okay. Yeah. Wait, but this is not for this. Am I in the right question? Oh no, I switched questions by mistake. Haha. So let me see this solution that I have here. So brute force, yeah, this is the first approach that we tried, which is the double loop. In this case, they didn't really... And let me see it in Java just so that it makes more sense. So in there, they just used the brute force. It's the double loop. That works, but it might just be slow. Then they did a 2-pass hash table. So yeah, so a hash map. Hash table it's called in other languages. They might call it like hash table or dictionary or something like that. So they did this one, kind of similar to what we did over here. And then they also did one which seems to be the fastest. That is that they're able to do it in one run. And basically what they're doing is that, oh yeah, this is interesting, right? Like they don't have to run through the array twice. Like just as they're going through the array, they're adding items and like checking from there, right? Because this works because you don't have to, or you can't use the same item twice. So they're just going through it once, and then they're just comparing the values. And if they didn't find it or anything, they just add that item over there. So this is also a great solution, and this will actually be an improvement of what we're doing because we get rid of a for loop completely, and then we just need to run one time. So this is cool. This is a cool solution. All right, let's see. Coop. Let's see 443. One sec. Let me try and get to it. 443, I don't know what I have here. Where the heck is 443? 8, 10. Okay, passed it. 9. 4 for 3. String compression. Given an array of characters chars, compress it using the following algorithms. Begin with an empty string. For each group of... Is this the one that you're looking at, though? String comparisons, this one right here. I think they're numbered right? Like it should be the same numbers everywhere. So I think this is 4 for 3. Yeah, so this is it. Okay, so given an array of characters chars, compress it using the following algorithm. Okay, so we're given a list, or an array in this case, of different characters. Compress it using the following algorithm. Begin with an empty string s, and then for each group of consecutive repeating characters in characters, if the group's length is 1, append the character to s. Otherwise, append the character followed by the group length. The compressed string should not be returned separately, but instead be stored in the current input character array. Note that the group lengths are 10 or longer, will be split into multiple characters in chars. After you are done modifying the input array, return the new length of the array. You must write an algorithm that uses only constant extra space. Okay, so yeah, in this case, they're asking us to do that, constant space, right? Like you want to make sure that you're not keeping any other array or any other hash map or anything like that. So let's go ahead and take a look at this. How long do you think is enough for trying to solve a problem before looking at the solution? Depends on where you are and how soon you're trying to interview. But typically I try to do like about 1 hour. So I try to do something like between 30 minutes and an hour. If I don't, if in 30 minutes or an hour I don't solve it, then I just look at the solution, because after that I'm just losing time. Like I'm not really being effective per se. Like after an hour I'm just losing time. It's a whole lot easier if I just look at the solution and try to like understand it. Look at the solution and also try to code it yourself, right? Like try to actually write the code for the solution, and then just make a note to come back to that problem like a few days after, just so that you can come back to the problem and try to solve it yourself now. But yeah, I think an hour it's more than enough, just because after that your brain gets tired, like you're not really looking at the thing right. So it's like kind of tough, but it really depends on everyone. Like as Scoop is saying, like I try until I don't make any progress in the logic. So some people might want to try longer. I personally, I don't know, I feel that it's like 1 hour should be more than enough. But really depends. Okay, so let's take a look at this right here. Let me just read this again to make sure that I get everything that's happening here. So, given an array of characters char, compress it using the following algorithm. Okay, so we begin with an empty string s, and for each group of consecutive repeating characters, so we're going to have repeating characters. So for example, here we have A repeats twice, B repeats twice, and C repeats 3 times. So we would have the output returns 6. Well, what is this returning? Oh, okay, it wants me to return the how many items are here, and then we are modifying the actual character array here. So we return 6, and the first 6 characters of the input array should be A2, 2 because we have 2 items here, B2 because we have 2 items here, C3 because we have 3 items here. So the groups are AA, BB, CCC. This compresses to A2, B2, C3. Now, if the characters is just one item, like for example here, then we just return 1 and it's just a character. Okay, so we only do the number if it's more than 1. If it's just one item, then we just leave it as is. Like for example here, we have return 4. The 4 space character of the input are this. Okay, so the array should be A, because A doesn't have anything, B, and then we have 1, 2. And the reason that we have 1, 2 is because it's actually 12 items, right? What do we have here? 6 and 6, yeah. So we have 12 items. They just ask us to break it up. If it's more than 10, we just break it up into 2 items. So what have you tried so far, Coop? Like wow, talk to me about your approach. Like what have you been looking at so far with these examples? So like I think we need to keep track to some extent of like where, like I'm thinking that this is something like a 2-pointer approach kind of thing, because I want to keep track of like not only the items that I'm looking at, but where in the position I can where in the position I can actually do it. So I'm thinking that, yeah, like I would probably use something like a 2-pointer approach just to keep track of the item where I need to write stuff. Does that make sense? And I can try and code it as well, but yeah, I think we can have, like, we can go through the whole array, start reading items, and then we are going to keep like some sort of pointer or variable that's gonna let me know like where to write the next item, right? Because since I'm gonna try and do this in place, I can't go back to the item like later on. So I want to make sure that I understand like how many items I've seen. So I was counting the number of occurrences using 2-pointer, ij, and when count is greater than 1, only then I write into the same array chars with current character and also count to next position. Okay, that seems like what I would do. Where are you using extra space there? Because I saw that you want to do it in constant space. Where are you using extra space? If the count is 1, which is initialized value, then only store the current character. Right. Oh, so you're storing, like, you're counting the frequency somewhere? Like you're maybe keeping a hash map or something of the items that you've seen? Or like where are you using, or you just haven't solved it yet? Just trying to understand like what you have done so far. Yeah, I think we can do something like that. I think we can do something like what you're doing, and I don't think we need any extra space, to be honest. You can share the code if you want. We can take a look here. But if you want, we can try and take a look here at some solutions. So, okay, what do I want to do here? I want to probably have 2 pointers, one where I'm writing and one just kind of like the start of a group. And I'm going to check if we are at the end of a group with the same character, and then write the value at wherever I need to write the value at, right? And then just keep going with the same thing. And then what are they asking us here to do? They're asking us to write an algorithm that uses only constant space. Okay, so they ask us to do constant space, but they don't have any necessarily like anything on our runtime. So let's try to take a stab at this. So let's go ahead and set something here. I'm gonna call it anchor. And this is just gonna be the start of the current group of characters, right? So we're gonna have something like, here's the start of the current group of characters. So this is just gonna let me know where in my process I'm at. I'm gonna have another one that's just gonna be like how many items I've written. So the position to write, like, you know, this is gonna keep track of where I'm actually gonna be writing if I need to write. So this is gonna be the position to write, or, you know, the length. I guess they're asking us to return the last length, right? Like 6. So that's just the items here.
Could you try again?
No, Siri, I'm not talking to you. What are you talking about? So yeah, this is gonna represent kind of where I'm at. And just to keep track, let's go ahead and keep my items here. So I can start with this, right? I can start with this and go through my items. So I'm gonna have something that's gonna keep track of my current group of characters, like where they start, so that I know, like, okay, am I still in a specific value or in a specific group? And then another item or another pointer, variable, or whatever you want to call it, that's gonna keep track of where I'm gonna be writing. Now let's go ahead and loop through here. So I'm gonna go through my whole array. So n is just the amount of characters that I have here, and then I'm gonna increment this. So I'm gonna be reading items, and this is kind of like a buffer, right? Like I'm gonna be reading items one by one. And then what do I want to do? So if the group's length is 1, append the character to S, like that's it. Otherwise, append the character followed by the group length. So for example, here A is equal to 2, B is equal to 2, C is equal to 3, but in this one, since it's only 1, so okay. So if the group length is 1, append the character to S, otherwise append the character followed by the group length. The complex string should not be returned separately, but instead be stored in the input character array. And the items that are 10 or longer will be split into multiple characters. This is the only one right here that's like throwing me off, to set it into different ones, but we'll get to that as we get. After you're done modifying just return the length of the array, okay, of the array that I added, right? Because originally it was 1, 2, 3, 4, 5, 6, 7, but we returned 6 because, well, the first 6 items are the ones that are holding. Does that make sense? So what do we want to do? So since we have our anchor, that's gonna be kind of keeping track of different things. That's gonna be the start of my current group of characters, and I'm reading items onto my characters. Like I'm reading items from my array. I'm going to check if we're at the end of a group of the same character, right? Because we want to go. So if I see A, I'm good. I'll check the next character. Is it A as well? And then I'll keep doing that until I'm no longer in the same group. So if my characters, what do I want to do here? So I'm going through my reads, and I want to check if my read plus 1 is equal to the item, so if I'm at the end of my array, or the character that I'm currently looking at is not equal to the character that comes after that, right? So why am I doing this here first? Because I'm checking, hey, I'm at the, am I gonna get to the end here? Like, am I at the end of the road here? Or if the items don't match, right? Like if I'm currently at the beginning of the array, or if I'm currently here on the second item at A, and the next one that comes is B, and they're not the same, then I know I'm at the end of a group, right? Does that make sense so far? For sure, Mohammed. Take care. We have to consider case when occurrence of a char is greater than or 10, so gets to 1 and 0. Yes. So we have to consider that, because we need to split them into, like, you know, if it's 10, it would be 1 and 0. If it's 12, it will be 1 and 2, and so on. So we do need to consider that as well. So, and we'll get to that in just a second. So for now, I'm just checking. Am I at the end of my character array? Like, am I at, at the end of the road? Or am I at the end of a group, right? So here, and check if at end of array or end of group. So if I'm at the end of the array or I'm at the end of the group, then what I'm gonna do is I'm going to set up, right, my write. So that's the place where I'm gonna be writing in my items, right? Like wherever I found my end of the road, that means that I'm at the end of the value. So I'm gonna do this. I'm gonna check, and this is anchor. So what I'm gonna do is that I'm going to write the value at the position of my current, position or length. And this is or length. And I'm gonna set it equal to whatever value I have at my anchor, right? Like whatever my anchor was. So the start of my current characters. So for example, if I'm at 0, then I would add A as my initial item of my array. And then in here, if my read is greater than my anchor, which could happen because I'm already way past the value, right? Like because I saw multiple A's or because I saw multiple C's or whatnot. So if my read is greater than my anchor, let's get how many items I actually have. So I'm gonna remove anchor minus 1. Sorry, anchor plus 1, because my anchor is gonna be, I'm trying to get the count, and if my anchor is indices, I don't want to use the index. I want to use the actual count. So I'm going to check, okay, if the read is greater than my anchor, that means that I have more than one item. Then I'm going to check the count, which is just going to be read minus my anchor plus 1. And then, what do I want to do here? So if my count, because this is where it gets interesting, because my count is going to be, my count can be more than 9, right? Like as you mentioned, Coop, it can be like, for example, 10. So my count can be more than that, and I need to split it. So how about we transform my count into a string, and then just like add the values that we need to add, right? Like if, for example, I transform 10 into a string and I do 1, 0, and then I transform this into a character array, I would have 1, 0, right? So I can just transform my count into a string and then get a character array from it. And this is just an example. Like you can probably do this with math, like using modulo or division. Like with modulo and division, you can remove items from the back of an integer, or you can start like getting single digits from an integer. But just for this use case, let's go ahead and go with this approach, where I'm just going to transform it into a string and then get the character array from it. So let's just keep that for just example. Okay, so what I'm gonna do is the following. Let's go ahead and just get here my char array. So let's go ahead and call it here like count char char array. I don't know, I don't have a better name for that. So in my count char array, what I said I was gonna do is I'm going to then to string, not to binary string, just to string my count, and then to char array. Right, so what am I doing here? Like for example, if I have 10, I'm going to convert it to a string, which is going to give me, a string containing 10, and then I'm going to turn that into a character array. And this might be good if we don't have like, unless for some reason we just have like a million repeating characters. This shouldn't really be an issue. This should at most be like, whatever, let's say 100. So at most it should run through 3 items, so it shouldn't really be that much of an issue. And then I'm going to loop for every character in my count char array, and I'm going to write them to my array, right? Like for example, in here, let's say that we saw A and then we saw A, right? So we saw the first A, we saw the second A, and we're here at the end because now we're at the end of my group, right? So what I would do here is that I need to add my A, but then the next item that I need to add is the frequency of it. So in this case, this is going to be the frequency is 2. So in this case, the count is going to be 2. I'm going to transform it onto a string, and then it's going to be a character array with just 1 item. So in this case, my count char array is going to just be an array containing 2. And then I need to add that onto my original characters. So I think it's called cars, write plus plus, and then I'm just going to set my C. And this takes care of when we have only 1 item. Only a count that's less than 9. And it also takes care if the count is, as we saw here, if the count is 10 or more, then this will split it into the specific values and write what it needs to write. Does that make sense so far? I hope that makes sense so far. If that doesn't make sense, make sure to let me know so that I can try to explain a bit more here. But yeah, so far this should take care of adding the counts and splitting them into multiple values. And then okay, so let's just run this back, make sure that we're doing what we need to do. So I have my anchor, which is just the start of my current group of characters, my right, which is just the position, and then I have n, which is just the amount of characters that I have. I'm going through every item in my array, in my character array. I'm checking if I'm at the end of the array or my characters are not I'm not still in the same group, or I'm at the end of the group per se. Then I'm going to write that value to my array, and then I'm going to add the frequency of it. So I add whatever value it is, and then I go through the frequency, and then I add what I need to add to my array. I think we're good. Then what I want to do is just set my anchor to read plus 1, because I want to be able to increase what I'm doing, right? Like if I'm already here at the end over here, so I'm at A, I don't want to continue to be at A, right? Like I want to make sure that now I'm on the next anchor. So I'm going to go ahead and increment that by 1, just so that I can have my anchor be the right value. And then I think at this point we're incrementing our right when we need to. So we're going to increment it every time we write a value, or every time we write the frequency or the count of how many items are in that group. And I think after this, then I can just return right? Like at this point, I can just return right. And let me just make sure here the algorithm, if the group length is 1, just append the character, so this should take care of that. Otherwise, append the character followed by the group's length. Yeah, and if the items are more than 10, or 10 and more, so that means it's double digits or triple digits or whatever, then we split them into specific items, and then again, this takes care of this. And lastly, we increment our anchor, and then we return our right. Coop, I think this is it, Coop. What do you think? I don't know, I haven't written it. I haven't run it yet. But I think this makes sense. What do you think? Correct me if I'm wrong, or maybe this doesn't make any sense, but I think this is it. I think this is all that we need to do. I'm gonna run it in just a second. But I think this is it, dude. So let me actually run it. I don't even know. Yeah, there we go. Boom. Boom. So the output was A2, B2, C3. A2, B2, C3. And we are passing all of them. And then if I submit this, fingers crossed it passes all of them. There we go. 1 millisecond and it beats 99%, 99.5% of users. So yeah, this is it. I'm curious to see your code though, like, because you said that, I believe you said that, that you were doing something, so you were going for, I'm trying to do O of n and space, but it's not passing for some test cases. Oh, okay. So you just didn't have the right values. I'm curious to see, like, what was the confusion for you, like, where were you getting confused? Because, yeah, I think at least for me, the most confusing part was just this, because we need to split the whole thing, right? And that might throw you off. But, dude, this is just like a simple, my code may look funny, I was trying. That's fine, dude, that's fine, like, I mean, the more you try, that's how you get the confidence and that's how you get the skills. As I always say, try to code it, try to do like brute force approach if you don't understand, or if you just want to, like, get something working, try to do an approach. And if you have to use like extra memory or extra space for some reason, then you use extra space. First, make sure that you can solve it and then try to improve it. But always try to go for a solution first. Don't try to just like do the best, most optimal solution the first time, because you're just losing time. And if you are in an interview, you only have so much time, dude. So you want to make sure that it's like, you want to make sure that you have the right thing. It's not allowing you to share the link. Well, that's fine. I honestly have no idea how to set that up here. So I don't know how to set, like, is there a setting that I can set up here so that it allows you guys to send links? I don't know, but you can copy this approach. I would recommend study this approach. I'm not sure if this is the best approach though. We can take a look at this other approaches that some people did here that were like 0 milliseconds, but I would say this is simple use of my 2-pointer, but yeah, look once, please. Look at what, your code or the 0 milliseconds approach. I think I have menopause, dude, because like sometimes I get super cold and sometimes I get hot. So I have like a heater here, but then I turn on the heater and I start sweating, and I turn off the heater and I start freezing. So it's like, I don't know what I have. Look at your code. I just don't know how to receive it. Do you have me on Instagram, Coop? Like, if you have me on Instagram, send it on Instagram and then I'll take a look. Like, I can open it here. Or if you want, just send it to my email too. So yeah, if you're following me on Instagram, send it on Instagram. If not, you can send it to my email and I can try to take a look. That's my email right there. I shared it on the chat so you guys can see it. But yeah, send it to me and we can take a look and I can try and see what the approach is. But in the meantime, okay, so let's actually take a look at the runtime complexity of this algorithm right here. What's the runtime complexity of this algorithm? So I'm gonna ignore constants and crap like that just because to me it's not really necessary. So I'm just gonna look over here at the loops that we have. So we have one for loop that's going through every item in my array. So over here I'm gonna have n times. So I'm running n times over here. And then in here I'm just doing checks, like let's say this is just 1 plus 1 plus 1, whatever. We're just doing like checks and additions and whatnot, so that I don't care about. And then we have another for loop here, and this for loop is gonna run on k times, where k is the length of the count. So if we have, like, for example, 9, then that count is gonna be that count 1. And if we have like, for example, 12, if we have, for example, 12, that count is gonna be 2. So what are we running here? We're running n times k potentially, right? Like in some cases. So I think this is gonna be n times so of n times k. Where n is the amount of characters in my array, and k might be negligible, unless, as I said, like unless we have an array with 1,000,000 characters and every single character is the same, then this second loop really is not really gonna matter at all. Like it'll probably run 1, 2, 3 times at most, 4 times if we have like 1,000 characters. But this shouldn't really be that much. So we're running an O of n times k, but it's not really bad. Okay, so you send it through Instagram. Let me take a look. Let me open my Instagram here. See if I can take a look. How do I get to my messages? Okay. Oh, I see it. Is it like a paste bin thing? Like a URL that says paste bin? I think that's you. I don't know, dude. Like lately a lot of people send me crap, so I'm like, I don't know if this is you. I think this is you. So let's take a look at that. Okay. Alright, so let's see here. If character instant length is equal to 0. Okay, this is like your base cases. This is fine if you want to do it, because like this way, if you have like 0 or 1, you instantly know that you can just return this right here. Yeah, you can easily do this right here. Base case, this is totally fine. I don't have any issue with this. That seems good to me. Then you're declaring an index, I, j, and current count. Okay, I have beef with this already. Why do I have beef with this? Index and I, to me, sound like the same. As I always try to stress to people, it's make your variables like understandable. Like, what does your variable do? Because like here, I don't know what index is and I don't know what I is. Like, of course, I can try to take a look at the code, but now you're making it so hard. And not only on other people reading your code, but on yourself, dude. Like, it has happened to me so many times that I write some code and I try to take a look at it 3-6 months after, and I have no idea what I wrote. So, similar to what I did here, try to set your items to, like, your variables to something meaningful, just so that you make it easier to understand. But okay, we'll take a look here. So okay, I'm declaring index as 0, I as 0, j as 1, j as 1, and the current count as 1. Okay. Then while I is less than the characters at length minus 1. Okay, so I'm going all the way to the end minus 1. So I'm going to go to the item right before that. And my j is less than the characters at length. And my j is less than the characters at length. Then if that is the case, so if the characters at I is equal to the character at j, then my current count plus 1 and my j plus 1. Okay. So if they're equals, that means indexes for sorting result character at the position. Okay. I'll get to that in a second. Yeah, I see what you're doing, right? Like that's kind of like what I had here as my right variable or something like that. Okay, so if my character at I is equal to my characters at j, that means that, I'm still in the same group. So I'm going to increment my current count and my j. Okay. So I'm not sure that this... Are we resetting j? No, we're resetting I. Okay. So, okay, we increment those two if they're equal, because we're in the same group. We increment the current count, and then we just increment our second pointer. And my I haven't really moved at all. Then I'm going to check if the current count... So, if I'm at a point where I'm no longer in my... If I'm at a point where I'm no longer in my... And I hope that you guys can see my screen, dude. I hope I'm not... Oh, okay. I'm sharing the browser. I was like, I hope that I'm not just sharing a screen. My bad. Okay, so if the current count is greater than 1, and the only way that we get to this else is if my group is over, right? Because my characters are no longer the same. So if I ended my group and I'm in the new group, then if my current count is greater than 1, I'm going to set the index, so it would be at 0, to be the character at I. And then if the current count is greater than 10, okay, so we set this, if the current character is greater than 10. So yeah, you're doing something similar here. Character from digit, no idea what's happening here though. This is weird. Like, I thought this was already taking care of it. No idea what this is doing. Because this seems like you're doing the same thing twice. Because if the current count is greater than 10, then we do this and we add the characters. So we would add, like, for example, if it's 10, first thing that I see is that the current count, you should have like a greater than or equal, because you also want to do 10, right? Like 10 is still your valid value that you want to split. So, yeah, I don't see why you can't just not do split there. But for 10, because in this case, you're only doing it for 11. So I would do greater than or equal to 10. And then I would do this. And then I have no idea what this is doing, dude. Like, not sure here. Because if anything, I would put an else, because I think that this is when the count is not greater than 10. So when the count is like 1 through 9 or something like that, I'm assuming is what you're doing here. But you don't have an else. So at this point, if the count is greater to, yeah, it was supposed to write an else. Oh, okay. Yeah, cause this would be else if it's not greater than 10, or greater than or equal to 10. So we would do that, and then we would set our current count to 1. Okay. So you would set the current count to 1. Okay, that's fine. So you can start counting again. And if the count is 0, I'm assuming it's less than 1. If the count is greater than 1. If the count is 1 or less, there you go. So if the count is 1 or less, then I just set my character at the value, okay? And then I'm gonna advance my I 1 spot. Sorry, I'm gonna advance my I to where my J was, and then I'm going to increment my J. You can combine these two steps, by the way. You can do I is equal to J plus plus, and then it'll set the thing and then advance it at the same time. But that seems to be good. And then in here, if we went through the whole thing, then we do this again. Why do we do this again? Charts array, the copy range. Yeah, and I'm not sure about this line of code. So I'm not sure about this right here. I don't know if that was just like a copy paste from the other one, or if this is taking care of the last item. If by for some reason we left it behind. But I know that this right here is not necessarily right, because you are replacing the array. And if you look at it might work, quote unquote work, but you are replacing the whole array. And if you read the problem, they do tell you to do the things in place, right? Like, yeah, because it says to modify. I was not considering the like group of characters, so I put after it failed. Yeah, okay, that makes sense. Yeah, because if the last characters is missing there. But yeah, you want to make sure that you update your character array in place rather than trying to copy this. This is a very expensive operation here, because if your characters has, like as I said, 1,000,000 items, you're running through 1,000,000 items to set them into 1,000,000 items, and it's like kind of weird. And they don't care. Like, what I noticed originally is that, for example, if we take this example here that they give us, here, and then they expect the result to be this, right? You notice that it's 1 short of it, but since we are returning 6 as the count, the array in reality looks something more like this. This is what the array in reality looks. This one right here. It's just that since we're returning 6, they're just evaluating the first 6 items, right? Like, they're just evaluating this. So it's fine if you left the rest of the items in the array, because they don't care about that. They just care that you return the right number. So if you left the rest in there, then it's fine. So I don't think that you need to do this copy range thing, because again, as long as you return the index and you already modified the values in the different places, then you should be good to go. But so I don't see a need to do this right here. And yeah, I would just try to revisit this logic right here. I think you can cover it with one loop, with one iteration, even the last values, because this is already running towards the end, right? This is running up to like the last item. Well, if there could be a couple of edge cases in there just because of the way that we're running here, in that if my I, like if the item at the end, like for example, if I have something like this, A, B, C, if I have something like this, and let's say my I is here, and my, stop adding a freaking point, and my J is here, then at this point my loop would break, like it would get out of my loop. And yeah, I see your issue, right? Like you didn't really evaluate the C at the end because your loop already exited before you could even get to the C. So you never really looked at the C, and then at this point you exited out. So you might want to revisit that logic right there just to try and see if you can do it a bit differently. But yeah, you can kind of check the approach. I'm going to try and send you this approach over there too. How do I do this right here? Can I paste something new? Yeah, I mean, just by looking at it, I recognize that, right? Because your loop that you sent me was not getting all the way to the end, so it was like kind of like weird. Syntax highlighting, and does it let me choose a language? I don't know. I've never used the spaced band, so. Oh, there we go, Java. Okay, let me send you this. Create new paste. And then to share it, do I just copy the link? I want to share this approach with you. Yeah, I think the link is good. And I'm going to send it back to your Instagram. So I just share the approach with you if you want to take a look. That way you can, kind of compare it to what you're trying to do. And as I always say, try to check, like look at the approach and try to understand what we did. And don't try to memorize the approach. Like don't try to just like memorize the problem. Rather try to understand why we did what we did, so that next time that you see a similar problem you can use it. But yeah, this is just like a two-pointer approach, and it's using but it's like a weird two-pointer because we're just like using them to specify like where to start and where to write. And we have kind of like a three-pointer approach, right? Because we're really using a read, but that read is just like reading items from the queue. So that's not necessarily like a pointer per se. But yeah, that was a cool problem. This was a very interesting problem. Mainly because of that, right? Like they don't want you to have like a separate array. They want you to replace the array in place. And they also want you to like split the items into like two different characters and whatnot. So this was very interesting. I liked it. Very, very cool approach. This is why I like LeetCode, man. Like, and a lot of people are like, oh, but I waste time, or don't waste time on LeetCode. And I think was a friend was asking yesterday, like, oh, should I waste time on LeetCode? And I don't think that you waste time, dude. Like, all of these things do help you as a developer. Like, once you start writing code, once you start writing production code and doing more and more things, like, you realize that these things matter. Like, these things, it helps you with, like, problem solving, critical thinking, how to do things differently, how to think outside of the box. If I have constraints, how do I work under my constraints? So I honestly don't think now or ever solving LeetCode problems will be bad. Like, honestly, yes, they are hard. They are hard. But with practice, it all becomes a whole lot easier. The more problems that you do, you'll start recognizing patterns. You'll start like I don't know, it'll be a whole lot easier because you'll just see something. Oh, okay, I understand that. Boom. And then you go for it. So yeah, always learn the patterns. Don't memorize a specific problem, because a specific problem is not going to help you, but a pattern is going to help you. So always try to memorize the patterns. All right, so let's go ahead and go to another problem here. This one is very similar to the one that we solved at the beginning. But at the beginning, we were using, so we were solving two sum, which basically they were asking us to get two, basically they were asking us to get the two indices of two items in the array that add to a target value. But in this case, my array was just in any order, right? Like here, for example, we have 3, 2, 4, 3, 3. This one is actually sorted, but they don't really tell us that it was sorted anywhere. So for this approach, we needed to use extra space, or at least the approach that I went with is using extra space because I was using a hash map to kind of keep track of the items that I was seeing. Now, I have this problem right here. This is problem 167, and this is two sum, so it's asking us, it's pretty much the same as the problem before, but in this case, it's telling us that the input array is sorted. Very, very important thing to keep in mind. This is super important to keep in mind and to kind of keep an eye out when you're solving problems is what is the input that you have, right? And also in your interviews, you want to ask the interviewer like, okay, I'm receiving an array. Is the array sorted? Okay, can I sort the array beforehand? Like, you know, those kind of things. But in this case, it says that like it's using the array is sorted in this case. So yeah, so we have to do the same thing that we did before, return the two indices. But in this case, they say that the indices should be added by 1. Why? Because they want us to return the index from 1 to the numbers that length. So instead of going from 0 to numbers and length minus 1, they want us to return between 1 and length. So yeah, so in this case, they want us to return the index. So we're just going to add 1 to the index. I don't see any issue with that. We just return 1 to, the index that's by 1. It says that there should be exactly one solution. And I cannot use the same element twice. And it tells us that we must do this in constant space. So you see, this is right here why we can't use a hash map, because they want us to use constant space. Again, if you're in an interview and you can't come up with any other solution other than the hash map, go for the hash map. Remember, always a solution is better than very efficient code that doesn't work. So that's you know, always try to go for a solution, and then if you can't find a solution, you know, if they want you to actually improve it and whatnot, then you can improve it later, but definitely find a solution. Coop, 2-pointer would be better for 167, right? Left equals 0, right equal the length minus 1, and then if the sum is greater of left and right, then decrement the right, otherwise increment the left. If left crosses right, then no solution. Yeah, that's I think that's the solution right there, right? We're gonna use the 2 pointers, and the reason that we can use this is because our array is sorted, and that's why it's, as I said, it's so important to determine if the array is sorted, because if the array is not sorted, good luck. Like, good luck trying to do this with no extra space. It's like, I mean, if you figure it out, great for you, but if the array is not sorted, it's super tough to do it without extra space. But given that the array is sorted, we know that the items at the beginning are always going to be less than the items at the end. So we can do the exact approach that Coop said, we're gonna have 2 pointers, and let me just kind of show right here. So we're gonna have 2 pointers, and then we're gonna start one at the beginning and one at the end of my array. And then what I'm gonna do is I'm going to compare if the sum is equal to my value, then I found it, that's it. I break out of the loop, I'm good. If the sum of the 2 items where I'm at, right, I'm gonna be at the beginning and at the end. If the sum is greater than my target value, then I'm gonna move my right pointer 1 item down, right? Like I'm gonna move from the end of my array just 1 item down. Why would I do that? Like, why can I do that? Well, because my array is sorted, right? Like, if my array is sorted, like in here, and I'm at 2 and 15, for example, I'm at 2 and 15 right here, and that is greater than 9, right? Because 17 is greater than 9, then if I move my right pointer 1 down, then I know I'm decreasing my sum, right? Because my array is sorted. So if I decrease my left item, then I know that I'm decreasing the sum. It's just the only thing that makes sense, right? Because my array is sorted. I know for a fact that the number right before it has to be less than my current number. Less or equal, right? So if I move my right pointer down, then I'm decreasing my sum. Why would I move my right pointer down and not my left pointer up? Well, because same concept, right? My array is sorted. So if I were to move, let's say I'm at 2 and 15. If I were to move my left pointer 1 up, I'm actually increasing my sum. But I already know that I'm over my sum. I don't want to increase it more. I actually want to decrease it. So I want to make sure that I can find values that make sense in this case. So yeah, the approach I'm going to follow is the exact same approach that Coop had. So let's go ahead and do some coding for this. So in this, I'm going to go ahead and declare a left. Yeah, it's super clear once you understand this kind of topic. So like first you need to understand what the 2-pointer approach is, and 2, you have to identify that your array is sorted. Since the array is sorted, we can do this. So I'm gonna do left and right, and I'm gonna set my right at numbers the length -1. So I'm setting my left to start at the beginning and my right to start at the end. And then as Coop said, I'm gonna loop while my left is less than my right, right? So if I'm moving my pointers, I'm moving them down and kind of like closer to each other. So if at some point my left becomes my middle or crosses my middle, then I'm over. I don't want to keep going because I already checked all of the possible combinations that I could, and there's no, like, I didn't find any values. So if my left, so I'm gonna loop while my left is less than my right, then I'm gonna calculate the sum. So I'm gonna calculate the sum of numbers at left plus numbers at right. And then I'm gonna do a couple of checks. If sum is equal to the target, right, if I found my target, well, I'm just gonna return my new int array. And in here, I'm gonna have left and right, right? Because those are gonna be my indices. So I'm gonna have left and right, but they are telling us that we should return the indices of the 2 numbers added by 1. So for example, in the first example here, the indices are 0 and 1, but we see that they return 1 and 2. Why do they want us to do this? No freaking clue, but they want us to do that. So all I'm gonna do is just add a +1 to both of them, right? Because if I'm at 0 and 1 and they want us to return 1 and 2, then I can just add 1 item to that. Okay, cool. So if my sum is equal to my target, then I already found my value. I'm good to go. Great. If the sum is greater than the target, if my sum is greater than the target, as Coop said, I'm going to decrement my right, because as I said, we are over our sum. The only thing that makes sense is to start decrementing my sum or looking for values that are less than that. So I'm gonna decrement my right, and then I'm gonna continue. Why? Because I know I don't need to check anything else at this point. I'm just going to continue. And you can do if else or else if or whatever you want to do here, but I don't know. I personally don't like if and else. I feel it makes it like super complicated to read. I like to do like either return or continue, just so that I don't have to do like an else. But okay, so if the sum is greater than the target, I'm gonna decrement my right. Sorry, I'm gonna decrement my right and move it down one spot, and then I'm gonna continue with my loop. And lastly, if my sum is less than my target, then if my sum is less than my target, I'm just going to increment my left. And if we went through my whole loop, let's say I went through my whole loop, and I didn't find, I never returned anything here, like I didn't find a sum that matched, then I'm just gonna return an empty int array, because I didn't find any values that matched. And that's it. This is pretty simple. Look, we're using constant space. Why constant space? Because it doesn't matter how large my numbers array is. I'm always just storing 1, 2 variables, 3 variables. So I'm just storing 3 variables regardless of the size of my numbers. And I'm running through at most n times. So I'm running linear time, because like worst case scenario is kind of like this one, where I moved my pointer all the way from 15 to the beginning. So worst case scenario, I'm gonna move one of the pointers all across the array to find my values. So at most, I'm running in O of n. So this whole algorithm should run runtime O of n, and it has a space O of 1. And that's pretty much it. Let's run it. Make sure that it works, first of all. There we go. We do pass the test cases here. And then as I submit it, yeah, we're running 3 milliseconds. We're one of the fastest solutions over here. Yeah, it surprises me that we're only beating 26% of people, but hey, I think this is a great approach. So yeah, for this case, since the array is sorted, I can use 2 pointer, and then I can just follow that pattern, right? And this is where you need to start thinking like, what are the properties that I have? What makes sense logically, right? Like, since my, what I explained at the beginning, since my array is sorted, then I know that if I want a sum that's less than the current one that I'm looking at, the only thing that makes sense is to move my right pointer down, not to move my left pointer up. And one thing that I always recommend people, or as I always say, is solve the problem before you write code. Let me repeat that to make it very clear. Solve the problem before you write code. Why? Because writing code is the easiest. Writing code is the easiest thing ever. Like, you just have to write the code. The difficult part is solving the issue or solving the problem, right? So always, while you guys are in interviews or you're trying to solve a problem, solve the problem first. Like, you should have in your mind what the solution is before you write a single line of code. So just as Coop did, and as we covered before, even writing the code, we already knew, okay, I'm gonna use 2-pointer approach. I'm gonna start one at the beginning and one at the end. And if the sum is greater, I'm gonna try and decrease my right pointer. And if the sum is less, then I'm gonna try and increase my left pointer. So we had already solved the problem even before we wrote code. Why? Why do this? Well, as I mentioned, that is the hardest part. If you start writing code, you're going to confuse yourself. You start working the code to solve the edge cases rather than trying to write good code or trying to write a good solution, because you don't have the solution yet. So you're just like going through the specific test cases and trying to make sure that you can pass some of them. But it just becomes a mess, because then you'll start adding stuff on top of other stuff that you have. And it's just going to become complicated. So, one, it helps you with knowing what you're going to write before you write it and not getting confused. And two, it also gives the interviewer the opportunity for like to help you. It gives the interviewer the opportunity to help you, because if I'm saying I'm talking about a solution, right? And I'm like, let's say I'm talking to an interviewer, and I'm like, oh, okay, yeah, for this approach, I think I can use a hash map, and we can save the values, and then I'm gonna compare if the sum matches. And the interviewer can come back to me and tell me like, hey, you know, that might be a good approach. That might be a good approach, but we need to use constant space. So how about we think about something else? So now the interviewer is helping me before I waste 30 minutes trying to write some code that doesn't work, or it's not what the interviewer is looking for. So always try to come up with a solution before you write code, and talk to the interviewer about it. Let the interviewer know like, hey, I'm thinking of doing this, this, and this. You know, do you think that's a good approach? And then the interviewer will, like, more often than not, the interviewer will help you. And every interviewer wants to make sure that you know how to communicate your, every interviewer wants to know that you can communicate your thought process, and you can explain how you come up with solutions rather than just the coding by itself. So they want to make sure that you're going to be able to work with a team and work appropriately. So yeah, always solve the problem before you write code, and communicate with your recruiter so that you have the specific items. So all right. Okay, I wanted to actually like code an app today, but I feel it's like kind of late. I don't know what time zone you guys are at, but it's like 1 a.m. where I'm at. So I think we can go with probably one more problem, LeetCode problem, and then maybe tomorrow I'll try to do like an earlier stream, and then I'll build an app during the stream. So yeah, 234. Okay, let's see if we can do 234. 34. Palindrome linked list. Okay, give me just 1 second. I'm gonna get, I feel sick, so I'm gonna get something to just blow my nose. Give me 1 second, I'll be right back. Okay, I'm back. What app am I gonna build? I don't know. So what I was thinking is like maybe tomorrow I can join and then just talk to you guys, and then we can see like what app do you think would be cool to build. Of course, it has to be something small enough that I can build in a stream, like let's say a couple hours. But yeah, like my goal is to build an app that we can build during the stream. So I'm gonna stream it, and I'm gonna show you like everything from creating the project, setting everything up, you know, like designing it, what I think should go, what I think, you know, shouldn't go. And we're gonna see what kind of app. I'm not sure yet what kind of app. What is tech stack? What tech stack? I'm not sure either. I'll let you guys decide that. I was thinking like, so I can do maybe either a Python, like an API based thing. So I can do something with like Flask. So I can do like an API and then just like, you know, try to like fetch data from it or something like that. I can do Python with Flask. I can do JavaScript or TypeScript. So I can do like a Next.js app. So we can go and like build a website and then actually deploy it and all that. So a Next.js app, a Flask app, or we can do a Flutter app and we can build a mobile app with Flutter. So I could do either of those three, either Python with Flask, TypeScript or JavaScript in Next.js, or Flutter. I think those are just like the easiest to get started with, or like to build something fast with. But yeah, but I'll decide, I'll let you guys decide that tomorrow, like what type of stack, if we want to go with an API, or if we want to build a web app, or if we want to build a mobile app. And then we'll also try to decide on what app we actually want to build. Because you guys will be building it with me, so I'll be getting pointers from you on, what to add, what to remove, and so on. But yeah, we'll see what tech stack do you like, or what tech stack do you typically do stuff with. But we'll see. All right, shall we use some of this, solve this problem? Are we ready? Are we ready? And what are we thinking? I'm curious to know, like, what is your, like, have you attempted to solve this yet, or you haven't solved it? Okay, let's go ahead and get started. I think we can solve this last problem, and then see if we can do that. Not solve it yet, just start off solving now. Okay, so what can we do? I think with this, we might be able to average stream bitrate is too high. Huh. I didn't know that Twitch could complain about like the average time that it's running. But okay, let's go ahead and solve this then. Thinking doing a two-pointer approach. Right? This is interesting because we're using a linked list, right? And in a linked list, you don't have everything that you need right away, right? Like, they're just giving us the head of the item. So it can become a bit interesting over here. It can become a bit interesting. So I'm still thinking two-pointer. But you know what I'm thinking two-pointer as? Is to, because this is a single linked list, right? So it's not even a double linked list where I know the previous item. And it's not a circular linked list, which would be weird because, like, how is it a palindrome if it's circular? But it's a single linked list and we don't have any values. So, I'm thinking of something ugly, but maybe that's just the solution. What I'm thinking is, how about we use two-pointer to find the middle of the linked list, right? Like we can use like a fast and slow pointer approach just so that we can find the middle of the linked list. And then, like we can find the middle of the linked list, and then I think I'm gonna reverse the second half of that linked list, and then I'm gonna compare the first half with the reversed half. I think this is ugly, but do they give us any like constraints? Like, do they want us to be like, can you do it in O of n time and O of 1 space? Yeah, and I mean, if we traverse, like if I reverse my array and then traverse it, I think we're still doing it in O of n. So I think that should be good. As long as we don't have like any nested loops, and I don't think we're gonna have to have any nested loops. Like, I think we can just find the middle, right? We're gonna have to find the middle of the array. And one of the easiest ways to do this is, as I mentioned, like trying to do like a fast and slow pointer to find the middle of the array. And then I reverse the second half of the linked list so that I have, because if it's a palindrome, then if I reverse the second half, then my first half and my second half would be the same. And then I can just compare. I'm going to compare my first half with the second half. And then, or the second half that now is reversed, and check if the values are equal, then just go for it. If at any point the values are not equal, then that should be fine. Yeah, I think comparing that second item is the way to go. I think that makes sense to me. What do you guys think? And again, I don't have all of the details yet. I'm gonna code it in just a second, but I'm trying to just kind of get in my, wrap my head around of what I think should be the solution. I definitely think, since we don't have access to viewing the whole thing, like I cannot start a pointer at the end and then walk them towards each other as I would do with like a palindrome string. I think what I can do is just find the middle and reverse the second half. Find the middle, reverse the second half, then compare the first half and the second half. I think that approach works for me. Yeah. I think that's a good approach. So let's go ahead and do that. And these might be concepts that I do believe you guys should learn. So two-pointer has two ways of doing it, right? Like how we did it for this one, where we have two pointers and we start them at different ends. So we start one at the beginning and one at the end, and then we walk them towards each other. Or there's a second way for us to do the two-pointer approach. That is that we start both at the same spot, but one of them moves slow and the other one moves fast. So one item moves slow and the other one moves fast. And this is useful for doing things like, as I mentioned, finding the middle of a linked list, and also to find if a linked list has a cycle. So if you guys ever need to do like, if you ever need to solve a problem where they ask you to determine if a linked list has a cycle, definitely using the fast and slow pointer. And I think that is called the tortoise and the hare algorithm. Tortoise and the hare algorithm. This one, Floyd's tortoise and the hare algorithm, which allows you to determine if a linked list has a cycle in it. So you guys should definitely take a look at that, how this is implemented. But yeah, we're going to use something similar here to find that middle over there. So what am I going to do? Base case, if my head is equal to null, or the item right next to my head is equal to null, then I'm just going to return true. Why am I returning true? Well, it's you can search this up, but an empty string on an empty value in a value with a single character is technically considered a palindrome. I don't know why. Don't ask me why. Just for some reason, something that's empty and something that has only one item is a palindrome, because, well, if you look at it and you see like, and you see that, if you have like the letter A, or if you have the number 1 it doesn't matter what way you read it. If you read one this way or you read one the other way, it's the same. So that's still a palindrome. But whatever. Point is, if my linked list is no, or I only have one item in my linked list, then I'm going to go ahead and return true because this is a palindrome. Then let's go ahead and find the middle, right? So as we mentioned, we need to find middle of linked list. And for this, I'm going to have 2 pointers, as I mentioned. So I'm going to have a list node pointer that's going to be slow, and this is going to start at my head, and then a list node pointer that's going to move fast, and this is also going to start at my head. Then I'm going to loop while my fast is not equal to no, and the item right next to my fast is not equal to no. So fast.next is not equal to no, and fast is not equal to no, and fast.next is not equal to no. And in here, I'm just going to advance my pointers, right? So as I said, one of them is going to move slow, and one of them is going to move fast. What do I mean by one slow and one fast? Well, this one moves one step at a time, or one node at a time, and this one moves 2 steps, nodes at a time. Right, so these are gonna move one faster, like for every one that this one moves twice. And what this helps us is that once we reach the end with the fast one, my slow one should be at the middle of my linked list, right? Because if one is moving 1 at a time and the other one is skipping, like it's moving 2 at a time, by the time that my fast reaches the end, my slow one should relatively talking be in the middle. Should we consider the case for even length and odd length? I don't think we need to. I don't think we need to because of the way that that the 2 pointers try to find the middle of the linked list. So maybe let's table that for a second. Once we get to it, we'll see. But I don't think we need to specify that. Why? Because if I reach the same item, like if I start combining and like checking if the items are the same and they are not like they're an odd number, I think we would still flip them and then just compare the amount of values that we have. And then if we have one item that's left, we just leave that item at the end, right? Like for example, let me just try to visualize this. So if I have like for example one, our middle would be the slow pointer, yeah, because the fast pointer reached the end, so we're not gonna have that that there. So let's say that I have something like this, right? This would be considered a palindrome, right? Because I 1, 2, 3, 2, 1. So this would be considered a palindrome. But if I find that my middle, it's about here. So let's see our fast and slow pointer approach, right? Like on the first one, it would be here. On the second one, it would be something like here. On the third one, we're gonna be all the way at the end with my J, and my I is gonna be right here. And at this point, since the fast.next is no, we would end. And then at this point, I would flip the rest of my linked list. So I would do 1, 2, 3, and then I would compare it with the flipped version of this, which is gonna be 1 and 2. And then since I reach the end here, when I reach the end here, I would compare 1 and 1, 2 and 2, and at this point I break since I only have one item. Then I think I'm good, right? Like, because I compare just these two. I don't need to care about the last one because that's just an odd number. And let's visualize an even one, right? If I remove this item from here and I just leave 1, 2 to 1, this is still even. And if I'm checking my slow and fast pointer on the first iteration, we would be here. On the second iteration, my J moves 2 and my I moves 1. Then on my next iteration, my J gets all the way out of here. So this goes all the way past, right? Because it would be 1, 2. No, sorry. So if it was, yeah, because it was here, right? Because on the first one it moved 1, 2, it was here. Then in this one it moves 1, 2, and it goes out. And then I think we have right here our array. So this would be our middle. We would still compare from here down, and we should have the same item, right? Or am I looking at this? Am I looking at this wrong? So we'll have IJ, move this to 2, move this to 1, then get rid of this, get it out, while this goes over here. Moves 1 step, moves 2 steps. I think that makes sense. And then we try to flip our array right there and get the value. So let's go through some code. Maybe that might make more sense here once we were like going through code. So okay, I lost my train of thought. So okay, we're looping through this. Ideally, our slow would be representing our middle of our array. So once we get here, then we're gonna go ahead and reverse the second half of my linked list. So best way to reverse this would be just by setting a variable right here and then checking here while the slow is not equal to null, right? Because now we're at the middle. We want to keep and go through, reverse the rest of our array. So while my slow is not equal to null, then I'm going to go ahead and set my next node to slow.next. This is just like annoying to flip it, but that's fine. So slow.next is equal to previous. Previous is equal to the slow, and slow is equal to the next node. So I start flipping my stuff, and yeah, since I'm doing slow, then basically I'm just starting to like, you know, go back there. So I'm doing like a weird loop there. Then what do I want to do now? I do want to do the comparison, right? Like I'm gonna compare the first half to the second half, so I'm just going to call it like left and right. So I'm going to declare again other 2 nodes, and I'm going to start one at the head. What did I put here? So my left is going to be like the first half. I'm going to start at the head, and then the right, I'm going to actually start at the previous item, right? Because of the way that we're flipping stuff around. So I'm going to start my right node at the previous. Sorry, I'm going to call this right, and I'm going to start at the preview. So we have this right here. Okay, and at the end we get null, so that's why, right? Because we don't want to use slow, because slow is going to get all the way to null, potentially. But the last item in that second half, or sorry, the first item now in that second half is going to be my previous. So that's why I'm starting here left and right. And then I'm going to check. While my right is not equal to null, if the left, that val, is not equal to the right, not equal to the right, that val, then we return false. Also, this is just my personal convention, but if I have an if statement, a loop, or something like that that only has one condition, I am not using curly brackets. I know people have mixed opinions on that, but me personally, why write more code when you don't need to write more code? Like, you just need to have one specific item. So if I only have one thing, I'm not adding the the curl is there. And then I'm going to increment my left and also increment my right? Or advance it in this case. Because I'm comparing and I'm going, okay, are these two the same? Are these two the same? Are these two the same? And so on. And yeah, so I compare them. If I don't find the value, or if at some point the values are not the same, I'm going to return false. And if I went through my whole algorithm and I never returned false, that means that all of the values were the same at every point. So all of the values were the same at every point. That means that I got to the end and my thing should be a palindrome. So if I reach the end right here, like I never returned false here, if I reach the end, then I should have true. And I think this is it. Let's run it. Let's see. 2 test cases passing, so 1, 2, 2, 1 is passing. So this is an even case, and this is still an even case. So we only get 2 even cases here, which doesn't give me a lot of confidence. So I'm gonna submit this, and just to see, make sure that it works for every case. It works for every case. So I'm hoping that they have like test cases that are using odd size or odd length. I'm hoping that they do use odd length, because if not, this would be very, very bad test cases. But there we go. This approach works. Now, things to keep in mind, because they had some constraints, right? Like they want us to run in O of n and O of 1 space. So let's look at this. We have constant space because we're just storing variables. So I store a variable here, I store a variable here, variable, variable, variable. So still O of 1 a space. So constant space because I'm not using any like extra array or extra hash map that's gonna hold all of my items or something like that. So I'm still using constant space. So I check mark on that. And am I running in linear time? So am I running in linear time? Well, that's fine, that's fine. This one is running through the array or through the linked list, and this actually runs O of n, and actually less than O of n, because like we would be running on the fast one, so we would probably do something like O of n over 2. But again, if we simplify this goes back to O of n. So this is O of n, this is also O of n, and this is O of n. So at the end we would have n plus n plus n, which would be equal to 3n. But again, if we simplify this, we have that this is just O of n. So yeah, we're still doing O of n. We do have multiple loops, but all of those loops are individual, and each of them run at most linear time. So if we add them all together, we get 3n, but asymptotically, this is just linear time. But yeah, for me, that's all I can think of. Yeah. Awesome. All right, so we solved a couple of problems here. I hope that you guys learned a lot today. Thank you so much, guys, again, for sticking around. I'm not sure, is this a good time for you guys? I want to make sure that I'm streaming also when, like, you guys are there and, like, people actually get time to look at this. So is this a good time for you? Like, what time is it where you guys are at? Like, is this early? Is this late? I'm not sure. Like, should I do them around this time? So it's around 3 p.m. where Frin is. What about you, Coop? So it's 3 p.m., so that means it's the afternoon. If I do it earlier, that might be too early for you. You might have like a morning stream, Frin. So, but I wanna do it a bit earlier just so that I get more time with you guys. Because right now I'm doing what I did 2 hours today. I think I've been recording for 2 hours. Yeah, 2.5 hours. So yeah. Okay, and it's like 1 in the afternoon. So yeah, probably you guys will have, I'll try to do it a bit earlier, I've been starting at around 11 p.m. Pacific time. So I started like about 2.5 hours ago. So I'll probably start a bit earlier. Like I'll try to aim for like 8 p.m. Pacific time, or between 8 and 10. So I'll try to do it a bit earlier just so that I get more time with you guys as well. Like, I mean, 2.5 hours might be enough, but I want to make sure that we can build like apps and we can, do some pair programming and cool stuff as well. So you guys learn a lot. So awesome. Well, thank you very much, guys, for sticking around. Really appreciate it. Feel free to reach out to me as always on Instagram. I try to keep an eye on that if you have any questions or anything. And yeah, make sure to send me some questions and anything that you'd like. And I can either reply to you on Instagram or we can check it here on the stream and we can see, like, as we did today, right? Like we go through some problems. We try to figure out how to make them work. We try to figure out, best approaches, and I'll try to explain some of the things that I know, and what I don't know, we'll learn together. So, all right, guys. Well, thank you very much for sticking around. Have an amazing day for you guys on your side of the world, and then I'll probably see you guys tomorrow. So, stay curious. Keep learning, and I'll see you guys on the next one. Peace.